Let's talk about the limiting reactant, or limiting reagent, which is the reactant that is entirely consumed when the reaction goes to completion. Limiting reagent ultimately determines how much product can be obtained. If you have a reaction of reactant plus another reactant gives you product, if one of the reactants is consumed completely, then the reaction is going to stop. Okay, you need both components to form the product. So the reaction stops when one component, which is the limiting reagent, is exhausted. Let's look at a simple example of what we're talking about. For example, bicycles require one frame and two wheels. If you have 20 wheels but only 5 frames, how many bikes can be made? Well, here's my 20 wheels. Let's now add our 5 frames. How many bikes can be formed? Well, obviously only 5 bikes. So my frames are my limiting factor. I have an excess of wheels. We can do the same thing in an equation base in dimensional analysis. We can prove that our bike frames are our limiting factor. I can say 1 frame plus 2 wheels gives me 1 bike. That's my equation. Now if I take my 5 frames and do my ratio, I know for every 1 frame I make 1 bike from my equation here. I know that I can make 5 bikes. Do the same thing for wheels. I got 20 wheels. I know it's 2 wheels for every 1 bike. I can only make 10 bikes. Once again, we're setting up that units cancel. Well, you can see, if I talk about frames, I can make 5 bikes. If I talk about wheels, I can make 10 bikes. So the limiting factor here is frames. I can only make 5 bikes because once I run out of frames, I don't have enough frames to make any more. So the smaller value is the correct answer, or you could determine which one is the limiting reagent and only calculate that value. Either way is fine. Basically, we must find out which species will run out first because it will dictate how much product will form. And this is what we're going to have to do with moles. Let's look at this example. If 0.3 moles of zinc is added to hydrochloric acid containing 0.52 moles of HCl, how many grams of H2 are produced? So in essence, I know I got 0.3 moles of one reactant and 0.52 moles of the other. I want to know which one of these is going to run out because the one that runs out first is going to dictate how much product can be formed. So first we must calculate how many moles of H2 is possible for each reactant. So first off, got my 0.3 moles of zinc, and I know I got a 1-to-1 mole ratio between H2 and zinc from my balance equation. That tells me I can form 0.3 moles of hydrogen. We get 9 moles of zinc to cancel. I can do the same thing for the HCl. I know there's a 1 mole of H2 to every 2 moles of HCl from the balance equation. Once again, my moles of HCl cancels. And that tells me I have 0.26 moles of H2 possible of being produced. Notice 0.26 is smaller than 0.30, so this indicates that HCl is my limiting reagent, and that is the value I'm going to have to use to calculate the mass of H2. The maximum product possible is based on the limiting reagent. The smaller moles of product is the maximum possible based on the limiting reagent, which in this case is HCl. So I'm going to take that value to calculate my mass of hydrogen possible. We'll use the moles of H2 possible from the limiting reagent to determine the mass of H2. So I got 0.26 moles of H2 times my molar mass of H2. Moles cancel. And tells me I got 0.53 grams of H2 possible. That is the maximum amount of H2 that's possible in this reaction because the excess zinc is not going to help me form any product. Some caution here. I want you to look at the moles of HCl and zinc to start with. I had 0.3 moles of zinc and 0.52 moles of HCl. Notice that the smaller number of moles was not my limiting reagent. You got to realize you got to account for moles as well as mole-to-mole ratios. The limiting reagent is not necessarily the species with the smaller mass or the number of moles. You must account for the mole-to-mole ratio as demonstrated in this problem. You can't just look at the smaller mass and you can't just look at the smaller number of moles. You've got to account for that mole-to-mole ratio to determine which one's your limiting factor. Let's look at another example. If I have 7.36 grams of zinc and it's heated with 6.45 grams of sulfur, what amount of zinc sulfide can be produced? So I have my two reactants and I want to figure out how much product can be formed. So this is a limiting reagent problem because I have both components, masses of both components. So got to find out how many is going to be produced. So I got my 7.36 grams of zinc, my molar mass of zinc, my mole to mole from the equation, which is an 8 to 8, which gives me 0.1126 moles of zinc sulfide. Once again, filing, canceling the units. I'll do the same thing with my sulfur. 1 mole of sulfur 8, that's 8 times sulfur, which is 32, gives me my 256.56. And the mole to mole in this case is an 8 to 1. Once again, canceling units. Gets me 0.2011 moles of zinc sulfide. So my next question is, which one of these is my limiting reagent? Well, since zinc only produced 0.11 moles of zinc sulfide, that is my limiting reagent. And that is the one that's going to calculate my mass of zinc sulfide that can be produced. It's a smaller number of moles, therefore it's my limiting reagent. So I'll take that number and start off my calculation. So I have to take my moles and go to molar mass to determine my grams of my zinc sulfide possible. Units canceling again. This final number, this 11.0 grams of zinc sulfide, there's a name for that. That is referred to as my theoretical yield. That's theoretically how much sample that should form. Now, there's side reactions, there's loss of products along the way and all that, so it doesn't always, but that is theoretically how much that should happen. The theoretical yield of product is the maximum amount of product that can be obtained from given amounts of reactants. The percentage yield is the actual yield, experimentally determined, expressed as a percentage of the theoretical yield, the calculated like we just did in the previous example. Calculation looks like this. The percent yield is equal to your actual yield, that's your experimental, divided by your theoretical yield, which is what you calculated, time 100%. And you realize, though, that percent is a unit. It's not the percent on your calculator. So it's actual divided by theoretical time 100. To illustrate this, the calculation of the percentage yield, let's recall that the theoretical yield we calculated a second ago was 11.0 grams of zinc sulfide. Let's say experimentally we ran this experiment and we only obtained 9.32 grams in our final product. What's the percent yield? Well, it'll be your 9.32 grams of zinc sulfide, which is your experimental value, divided by your 11.0 grams, which is your theoretical, that's what you calculated it should be, time 100, which tells us is 84.7% yield. Remember again, percent is a unit, not the button on your calculator. Now, let's do a whole problem from top to bottom with the percent yield. So here I have 11.0 grams of methanol mixed with 10 grams of carbon monoxide. What is the theoretical yield of your acetic acid in the following reaction? If the actual yield was 19.1 grams, what is the percent yield of your acetic acid? Well, once again, I got two reactants, so I need to figure out which one's going to run out first, or if either one's going to run out first. So I got to figure out the moles produced by each reactant. So I'll start off with my 11 grams of methanol. I got a 1 mole to my molar mass of methanol. 1 to 1 between methanol and my acetic acid gives me 0.3432 moles of acetic acid. Same thing with the carbon monoxide, molar mass of carbon monoxide. It's a 1 to 1 as well. gives me 0.3570 moles of acetic acid. All my units cancel. Now I need to look at the two numbers and figure out which one's my limiting reagent. It's going to be the methanol because I make a less acetic acid product. So I'll take that number and convert that into a mass through molar mass. Units cancel. Tells me I got 20.6 grams of acetic acid. Remember, that is my theoretical yield. That's how much I should get. But experimentally, we went through it and we got our end product, we weighed it, and we only got 19.1 grams. So we need to figure out now what is our percent yield in this reaction. Percent yield will be my 19.1, which is my experimental value, divided by my 20.6, which is my theoretical, my calculated value, times 100, which tells me I got 92.7% yield. Homework 25, or a question similar to this.